Lesson 67. First, we'll start off with a review of equivalent equations. Remember, equivalent equations are ones where all the set of solutions, those are identical sets. So for example, let's look at these two equations. X plus y equals 4 and 2x plus 2y equals 8. These are equivalent equations. We can tell just by looking at them because you can get from this equation on the left to this one on the right by multiplying every term by 2. So we do the same thing on the left and the right of the equation. Multiply x plus y by 2, we get 2x plus 2y. Multiply 4 by 2, we get 8. So since by doing the same thing on both sides, we can get from one equation to another, we know by definition that these are equivalent equations. Be careful though, all the solutions have to be the same. These two equations, x plus 4 equals 6 and x squared minus 4 equals 0, you might be tempted to think they're equivalent because x plus 4 equals 6, the solution there, x is 2. X squared minus 4, does 2 work for that? Yes. 2 squared, 4 minus 4 is 0. However, be careful. When you see things like squareds, there's another solution here. Should be negative 2 also is going to work here. Negative 2 squared is still 4. Minus 4 will still get us 0. So these are not equivalent equations, even though at first glance they might seem to be. The main topic of this lesson is the elimination method for solving sets of equations. Now, up until this point, when we've had two equations like this existing in the same universe, as the curly bracket on the left tells us, we had used the substitution method to solve these. That works fine. But sometimes we'll notice that there's another method we can do also, the elimination method. And the way that this is going to work is this will let us get rid of one of our variables instead of by substituting for it, by finding out another way to write it using by manipulating one of those equations. Here, we're going to eliminate it directly, also called the addition method, because we're going to add the equations together. So notice here, these equations, x plus 2y equals 8. 5x minus 2y equals 4. Now remember, we're allowed to do the same thing to both sides of any equation. And in both of these equations, by definition, the left and the right are equal to each other. So if we add the same thing to both sides, we'll end up with an equivalent equation. And we notice if we add these equations just straight down, 8 plus 4 is 12 on the right there. X plus 5x gives us 6x. And 2y plus negative 2y gives us 0y. So 6x equals 12. Just by adding those equations together, which we're allowed to do, because 5x minus 2y is equal to 4, we're allowed to add this to one side of the equation and this to the other side of the equation because they're equal to each other. And we end up with 6x equals 12, at which point we can very easily see that x is 2. Then we can plug it into one of these equations, maybe the first one, 2 plus 2y equals 8, okay, 2y equals 6, and then y equals 3, and we'll see that our solution is 2 comma 3. So when you have an equation where one of them has variable being added and the other one has it being subtracted, that's often a good sign that this addition or elimination method is going to be a good strategy to use. Now, it won't always be as easy as this, where you can just add the two equations directly. Let's take a look at another example where we're going to have to get a bit more complicated. So in this example, our equations are 2x plus 5y equals negative 7 and 3x minus 4y equals 1. Now, we look at this and we say, I can't actually just add those together. It's not going to help me out. Because if I add them together, I'll get 5x plus y equals negative 6, which is an equivalent equation, but it doesn't actually help me because it doesn't get rid of one of those variables. And I can only solve things that have one variable at a time. But what we can do is before we add them together, we can multiply each of these equations, again, which is something we're allowed to do as long as we do the same thing to both sides. And so we see this plus 5y and this minus 4y, 5 and negative 4, we should be trying to get to the same number and its opposite. 5 and 4, we can get to 20 really easily with both of those. So if we take this first equation and we multiply the whole thing by 4, left and right. So on the left side, we'll end up with 8x plus 20y, and multiply the right by 4 also, so that it stays equal, stays equivalent. We get negative 28. The bottom equation, on the other hand, we're going to multiply by 5. And again, we're allowed to do this because we're going to do the same thing to both sides of the equation. Notice we do not have to treat these equations the same way. They're separate equations, so as long as we're doing the same thing on both sides of each equation, then we're going to be good. So this one will multiply by 5 on each side. 3x by 5 will give us 15x. Minus 4y times 5 will give us minus 20y. And then 1 times 5 will give us 5. At this point, now we've got plus 20y and minus 20y. We can add them together. 8 plus 15 is 23x. Plus 20y minus 20y is 0y. So plus 0, it's just the same thing. Equals negative 28 plus 5, or negative 23. Oh, look at that. I got a little worried there seeing that 23 coefficient on that x, because 23 is prime, and I was worried we were going to end up with something really ugly. But in fact, on the right, we get negative 23, so we can easily see that x is negative 1. Plug that into either one of these. Let's say the first one, so 2 times negative 1 plus 5y gives us negative 7. So it's negative 2 plus 5y gives us negative 7. Add 2 to both sides, we get 5y is equal to negative 5, and y is also going to be negative 1. So negative 1 comma negative 1 will be our solution there. So sometimes you're going to have to multiply them. Now we can also do the same thing, and we can eliminate x. We don't have to eliminate y. It's going to be a little bit easier because we already have a positive and a negative y, but we can eliminate x instead, and I'll show you how to do that as our last example. So the same set of equations here, so we should end up with the same answer, negative 1 comma negative 1, but this time we're going to eliminate x first instead of y. So here we look at it, we've got 2x and 3x, and we need to end up with x's that have opposite coefficients from each other, like we had the 20y and the negative 20y. So 2 and 3, since they need to be opposites, one of these is going to have to be negative. I'm going to do that to the first one, because then on the right, I'm going to end up getting rid of my negative there. So let's multiply the top one by something negative and the bottom one by something positive and see if we can get opposite coefficients on those. So 2 and 3, well, 6 is going to be an easy number to get to, so we're going to go for positive 6 and negative 6. So to get that 2x to negative 6, we'll multiply the whole top equation by negative 3. So 2x times negative 3 gives us negative 6x. 5y times negative 3 gives us negative 15y. And negative 7 plus, times negative 3 is going to give us 21. All right, now the bottom equation to get to positive 6x, we'll multiply by 2. So we get 6x minus 8y equals 2. And at this point, now that we have opposite coefficients on that variable x that we're trying to eliminate, we can just add them together. Negative 6x plus 6x gives us 0x, or just 0. Negative 15y plus negative 8y gives us negative 23y. And 21 plus 2 gives us 23. So we see y is still negative 1, which is good. We're dealing with the same set of equations. We should have the same solutions. And then we can plug that in just like before to either one of these, and we'll get that x is negative 1 also. So substitution is one option when you have these sets of equations to solve, but another one is addition or elimination.